Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 maths algebra, solving quadratic inequalities. Now, quadratic inequalities is on our work schedule. It is under equations and inequalities, and here it says quadratic inequalities in one unknown interpret solutions graphically. So in today's video lesson, I'm going to be concentrating on that. So let's have a look. So let's go look at the questions that involve quadratic inequalities, and this is from the November 2019 paper 1. And there's a question here, 1.1.3, x minus 1 into 4 minus x is greater than or equal to 0. Now the first thing that we have to do is make sure that it's factorized, and in this question it's already factorized. So let's go write that question down. 1.1.3, so we got x minus 1 into 4 minus x, and that's greater than or equals to 0. So once again, I said make sure that it's factorized, and we'll be able to factorize a quadratic equation in various ways. Now once it's factorized, then you need to get what we call the critical values. At the critical values, the sign of our expression is going to change. So now that's something that we need to look at as well. So the critical value here now, how you get your critical values, you should say x minus 1 equals to 0, therefore x equals to 1. 4 minus x equals to 0, therefore x equals to 4. I just simply took this minus x to the other side, it becomes positive x, right? Next thing that I want to do is I want to draw a line. Now this is the way I do it. I know some of you guys, you actually do the parabola as well, but it's all essentially the same thing. So let's now draw the number line, and let's put our values in order of the number line. So 1 comes before 4 on the number line. The next thing that I will ask students to look at is I want you now to work out one interval. So I normally look at the interval on the extreme right. So I want to substitute a value greater than whatever this particular value is, right? 4, right? So I want to look at what's my next integer value greater than 4. Well, it's 5, right? So what I want to do is I just want to substitute x equals to 5 into this particular inequality here, all right? So in the factorized form. So what I'll do is I'll just say 5 minus 1. Now I'm not interested in the actual answer. What I want to know is whether it's just positive or negative. Like 5 minus 1 is 4. It's a positive value, so that's going to be a positive times, remember brackets mean multiplication. 4 minus 5 is negative 1, so that's going to be a negative. Therefore, if I multiply that now, a positive times a negative is a negative. So therefore here, for all values now greater than 4, you're going to get a negative value, and you only need to work out one interval. So therefore, if that is negative, then this interval now is going to be positive, and then this one over here is going to be negative. So it'll be negative, positive, negative. So what happens is it just changes there at each critical value, the sign. Okay, now we go back to this particular question. Now it says here that they want you now to say where this thing is greater than 0. Greater than 0 in mathematics, greater than or equal to 0 means where is it positive. So we're looking for that particular sign there. And there you go, it's positive here. So therefore, greater than or equal to 0. Now when you're representing on the number line, remember that will be a closed circle. So there you go, that's your answer there. Now to express this particular solution now from a number line into set builder, notation will be as follows: x greater than or equals to 1 and less than or equals to 4. If you wanted to express the same thing in interval notation, it will be x element from 1, remember close bracket for greater than or equals to, or I should say square bracket, and 4 like so. Okay, but normally we just want the answer in set builder notation: x greater than or equals to 1, less than or equal to 4. Right, let's go look at another question. Now we look at a question from November 2018 paper 1. There's it here. So let's go look at the quadratic inequality. The quadratic inequality is 1.1.3, 2x squared minus 2 greater than or equals to 3x. So let's write that question down. So 1.1.3, 2x squared minus 2 greater than or equals to 3x. And now, so there we go, that's the question there. So they want us to solve this quadratic inequality. So the first thing now that you have to do in this case here is you have to write it in the standard form of a quadratic equation so that you can factorize. So that will be minus 3x minus 2 greater than or equals to 0. Now that it's in the standard form, now you can factorize than or equals to 0. So let's go for it. 2x times x is 2x squared. Factors of 2 there, it's a prime number, so it's only got two factors, 1 and 2. So I'm going to write here 1 there and 2 there. So remember, I need to get minus 3x in the middle, so that's going to be minus there and plus. Always check. If I multiply 2x times minus 2, I'll get minus 4x. If I multiply plus 1 times x, I'll get plus x. Minus 4x and plus x is minus 3x. 2x times x is 2x squared, and plus 1 times minus 2 is minus 2. So I check my factorization, so everything seems correct. So therefore now I need to get my critical values. Remember, in order to get your critical values, you need to take your each factor and you need to equate it to 0. So 2x plus 1 equals to 0, 2x equals to minus 1. So therefore you're going to get x equals to minus half. And then over here, we'll say x minus 2 equals to 0. So x equals to 2. Now that you got your critical values, once again, remember what we do. We're going to say you're going to draw the number line. You draw the number line, and minus half comes before 2. So that'll be negative half there. And then you'll put 2. So negative half and 2. Now let's do the same process that we did before in the previous example. What I want to do now, I want to substitute an integer value. So I'm going to substitute an integer value x equals to 3. 1 greater than that one, right, into this. So what I'm going to get here, 2 times 3 is 6. 6 plus 1 is 7. So that's a positive value. So therefore I'm going to get a positive times 3 minus 2 is 1. So that's also a positive value. So positive times positive equals to a positive. Therefore, all values that are greater than 2, I'm going to get a positive value. Okay, so positive, then that means inside of here now, in this next interval, it's going to be negative, and then that's going to be positive. Remember, it changes at each interval. Now let's go look at what they want us here to find. They're saying here greater than equals to 0. Greater than equals to 0 means positive in mathematics. Positive is that plus sign. So therefore, greater than equals to 0, there, close circle, greater than equals to 0, close circle, there you go. So my answer is going to look as follows. It's going to be x less than equals to minus half, or x greater than equals to 2. Learners, look at this next question now from the November 2017 paper, right? So here you've got x squared greater than 3 into x plus 6. So here you'll just open the brackets out. You'll say 3 times x is 3x, 3 times plus 6 is plus 18. You'll write in the standard form and you'll go through the whole process again. Basically factorize, get your critical values, and I want you to do that question on your own, right? So I'm going to look at one more question now, which is slightly different, and I'm looking at the question that appeared in the November 2016 paper 1. Now the reason that this is slightly different is because, as you can see, there's no constant term here, so you can factorize this quadratic here by removal of a common factor. Okay, so let's look at 1.1.3. 1.1.3. So here you got 4x minus 2x squared is less than 0. So let's factorize there, so we can take out 2x as a common factor. So we're going to say 2x, that's the HCF, into what we're going to get there, 2, right? 2x, remember 2x times 2 is 4x, and then 2x, so that's times minus x. See, 2x times minus x is minus 2x squared, less than 0, right? Less than 0. Now, so you factorize. After you factorize, same process, get your critical values. 2x equals to 0, right? And what else we're going to get here? 2x equals to 0, and 2 minus x equals to 0. So here we're going to get x equals to 0. That's going to be one critical value. And then the other critical value is going to be x equals to 2. I just take the minus x to the right hand side, x equals to 2 there. So let's draw the line. 0, and then comes 2. Same process. What I'm going to do, substitute x equals to 1 greater than my value on the extreme right over here, okay, which is going to be x equals to 3. So I want to substitute x equals to 3. Now if you substitute x equals to 3, 2 times 3 is 6. That's positive. So that's all I'm interested in, the sign. Positive times 2 minus 3 is minus 1. So that's negative. So therefore it's going to be minus. So plus times a minus is equal to a minus. Therefore I'm going to get negative there. If I get negative there, that means I'm going to get positive there and negative there. Remember, it changes. Okay, minus, plus, minus. You only need to work out one. That's why I work out the one on the extreme right. Now let's go look at what this question is asking me for. They're saying, where is it less than 0? Less than 0 means negative in mathematics. Negative. So therefore, where is it negative? And don't forget now, less than 0. So if I'm representing it with a number line here, it's an open circle. So there's it here. Negative is there, and also negative is there. So that's a number line. Now let's go represent the answer in separate notation. So that will be x less than 0 or x greater than 2. And that's my solution. X less than 0, x greater than 2. And that's how you work with quadratic inequalities. Learners, if you haven't subscribed already, subscribe to JR Maths. You can like my Facebook page, Justin Lazarus Mathematics. You can watch all videos in order of the work schedule on jrmaths.com. And I'll catch you in the next video.